Hello, welcome to our channel for probability and statistics. In this video, we will talk about confidence interval of population mean with unknown variance. So when we want to estimate a mean value called population mean, we usually take samples from this population and use the sample mean called x bar, which is a point estimate of population mean. Because if take many times of such kinds of x bar, a sample mean, it's usually different. So sample mean has also itself a distribution. So this is called a sample means distribution. And x bar compared with other kinds of estimate, for example, mode or median, x bar has smaller variance than any other estimators of the population mean. So we also call x bar is the most effective statistic estimate of the population mean. So if the sample size is not very enough large, or say less than 30 in this case, and the population mean is a normal distribution or very close to normal distribution. So in this case, the sample means distribution is very close to a t-distribution. It's called a student t-distribution with n-1 degrees of freedom. So we can calculate this statistic x bar minus population mean divided by the sample standard deviation divided by the square root of sample size. So this statistic t has a t distribution with n-1 degrees of freedom. So here S is the sample standard deviation. Because we do not know the population variance, so we have to use the sample standard deviation. So next, we can calculate the probability of this item between the range of minus t half alpha and positive t half alpha. This probability is 1 minus alpha. So if, say, alpha is 0.05, this is the significant level. So we can say we have 95% confidence to say the probability of this item is located in this region. So here t half alpha is the t value with n-1 degrees of freedom, above which we find an area of half alpha. And because of symmetry, an area also of half alpha will fall to the left of minus t half alpha. So we look at this figure. This curve is the t-distribution's density curve. It's very close to normal distribution when the degrees of freedom is large. But if the degrees of freedom is not large, the t-distribution has a little flatter shape, but also symmetric to both ends. So compared to normal distribution, it has a little flat but a longer tail. So half alpha here is associated with t value. It's called t half alpha. This is also, we can say, the critical value t half alpha. So this shaded region has the probability 1 minus alpha. So this too white area has the probability of half alpha. So we go further with the mathematical manipulation. We can get the probability of the population mean, which we want to estimate this value, right? So the probability of population mean between these two terms, x bar minus t half alpha times x divided by square root of n and x bar plus this item, this probability is 1 minus alpha. So which means we have 95% confidence to say the population will between these kinds of region. So confidence, what means confidence interval? This means if we want to do such kinds of experiments many times, for say 1,000 times, there is about 950 times that the true population mean will be located in such kind of region interval. But for the individual one time, for the specific one time x bar, we get x bar, we cannot say we have 95%. It will cover the true population mean. Because for the one specific x bar, and one specific standard deviation s for the sample, we can only say the population mean is in this region or not in this region, right? But we do not know the true confidence interval. So we only can say confidence, 95% confidence to say such kind of region will cover the true population mean. So this is say we have many times, not only one time, right? So for the specific one time only covers or not covers the true population mean which we want to estimate. So next we will take a look at an example. The contents of 7 similar containers of sulfuric acid, these liters, find a 95% confidence interval for the mean contents of all such containers, assuming an approximately normal distribution. So because we assume a normal distribution from the population, and the sample size is not large, only 7, so we will use t-distribution. And the solution is the sample mean and the standard deviation for the given data can be calculated as x bar equals 10, and the standard deviation is the square root of the standard variance, right? Standard variance is the mean square from the sample mean, then divided by n minus 1 here. So remember here, divided by, not divided by n minus 1. Then take a square root, we can get standard deviation or standard error from the sample. So from the t-distribution, we can get t 0.025 is 2.447 for 6 degrees of freedom. So the population mean, 95% confidence interval of the population mean is between this range, about 9.74 and 10.26. Thanks for watching.